Hello there and welcome to a brand new video. This is Hub Beyond Numbers, where we learn maths the easy way. Now in this video, we are looking at measures of central tendency, and specifically we'll be looking at the mean. In our next video, we'll look at mode and then the median as well. So when we talk of central tendency, when you have a data, you see, and you want to have an overview or a general overview of the data, what we use is the central tendency. You see, the central data, something like that. So there are three of this that you are supposed to know. We have the mean, then we have the mode, then we have the median. But for now, we are just looking at the mean. So when we talk of the mean, it is the sum of all the values in a data set divided by what? The number of values. It can also said to be the average. You see. So what the mean does is it tells us the typical what value or the center of the data. Okay. So based on the kind of data we'll be coming across, I've divided whatever we are coming to do into three. The first one is when you are given a raw data, just some few numbers, and you want to look for the mean. How do you go about it? We'll be looking at that. Then the second one is when you are given discrete frequency data. You see, you are given discrete frequency data. And then the last one is when you are given a grouped data. And with all of this, I'll just be solving one examples each, right? So just take your time and then understand these examples. Then you can also apply them in other exercises as well. So let's look at our first question over here. So for this very first one here, it says the ages of 5 students are 10, 12, 11, 13, and 14. And we have to calculate the mean of what? The mean ages. The mean age. How do you go about this? This one is just a raw data, right? So it is important we know the formula we need to apply for every type of data we are being given. Generally, it is all the same, but depending on how the data looks like, we write it in a certain way. So over here, we said the mean is equal to the sum of what? The data values. The sum of the data values. So with what we have over here, then I'm going to get the sum of the data values to be 10 plus 12 plus 11 plus 13 and then plus 14. Those are the data values. So we add all of them together. So adding 10 to 12 to 11, 13, and then 14, we get 60. So it means the sum of these data values is what? 60. Now that we have the 60, they said the number of data values. And how many data values do we have? 1, 2, 3, 4, 5. There are just 5 of them. So we have our 5 here, right? So the mean we are looking for, our mean is going to be equal to sum of all the data values, which was 60. So 60 divided by the number of data values, which is what? 5. So our mean is 60 divided by 5, and 60 divided by 5 gives us a 12. So the mean of their ages is what? 12. In other words, the average of the age is 12. With this, you see that calculating mean is very, very easy, right? So if you are given a raw data, this is what we do. Let's look at another one as well. Looking at this question here, we have to use the frequency table above to find the mean of x. So if you really want to do this, we have a formula for that. And this is the formula over here. Unlike the previous one, this data has been given to us in a frequency table. You see, and you don't want to write the number of threes you have, the number of twos you have, and all that. We want to use the frequency table. And the formula says we read it as sigma fx all over sigma f. To be able to evaluate this, what you do is you'd have to complete your table. All right, you have to complete your table. So I'm coming to redraw this table over here. So this is our table here. And the next thing we want to add is what? F times x. What does f times x mean? So for every frequency table, if you're able to get your x values and then your f values, if you want the mean, Then you are going to multiply your frequencies, each frequency by its corresponding x value. That is what we mean by fx, or f times x. So in this case, we have 2 times 3, which gives us a 6. Then 3 times 5, which gives us a 15. A 4 times 6, which gives us a 24. Then finally 5 times 2, which gives us a 10. If you're able to evaluate this, we don't have just fx, but then sigma fx. What this means is you're going to add all these values and then write their sum here. So we write our sigma fx down here, and summing all this up, we are going to get our sigma fx to be equal to, let me use a black for that, to be equal to what? 55. You can perform the addition. That is 6 plus 15 plus 24 plus 10. Then the next thing we need is the sum of our frequencies. The sum of our frequencies. And how do we get to the sum of our frequencies? You are going to add 3 to 5. These are the frequencies. So you are adding everything here. So summation of frequency. So 3 plus 5 gives us an 8. Then 8 plus 6 gives us a 14. 14 plus 2 gives us a 16. All right, so we have this 16. Then we now go on to evaluate our mean. So the mean we are looking for. By the way, we can write mean with this symbol. Right? So the mean we are looking for, whose formula is the sum of f of x all over the sum of f, or sigma fx all over sigma f, is going to be equal to the sigma fx give us a 55. Then the sigma of f gave us a 16. So you can evaluate this using your long division, and that is going to give you a 3.4375. So this here becomes the mean of this data set we have over here. So it's all about you knowing your formula, right? So for a frequency data, a discrete frequency data, as this we have over here, complete your table. You have the values of x, you have the values of f. Find your fx, you see. And if you finish, you sum up all the values of fx. You write that over here. You also sum up all the values of f and put that over here as well. Then your mean is just what? This over here, the sum of fx divided by the sum of f. And you are good to go. Now let's look at the last one, that is the mean of grouped data. Okay, so for this last one we are looking at, that is the case of grouped data. This is our frequency here, right? And we have to use the frequency table to determine the mean of the group data. In one of the previous videos, I taught on how to get your class midpoint. You see, so we did the class intervals and then the class boundaries, then the midpoint. That is the same thing we are going to apply here, right? So let's quickly look into that. Okay, so to use this grouped data to get our mean, we'll have to copy it again, right? So we copy it again, and this time around, our formula says we should multiply f by x. But we have our frequency. Meanwhile, this here is an interval, you see. So since it is an interval, you would have to get your own x. And how do you get your x? That is where the idea of midpoint comes in. So the midpoint of the intervals is what is going to serve as your x, right? I'm taking that again. The midpoint of your interval is what is going to serve as your x. And how did we see we get the midpoint of an interval? You add the upper limit to the lower limit and then divide it by 2. So for this here, we have 10 plus 19. That gives us 29. 29 divided by 2 gives us a 14.5. The same way, you have your 20 plus 29. Then you divide it also by 2. That is 49 divided by 2. That gives us a 24.5. And while solving for our midpoint, we realized in our previous lesson that it will just follow the same pattern. So if we have 14.5, 24.5, the next one is going to be 34.5. Then we have our 44.5. So with this, you are done with your what? X values. But frequency mean says we should find the product of the F values then the X value. So we are going to multiply the F by the X. That will give us our Fx. For the first one, we have 14.5. We are multiplying it by 2. Right? That gives us a 29. So we write our 29 here. Then the next one also, we have 24.5 times 5. That also gives us 122.5. Then we work 7 times 34.5. That also gives us 241.5. And then finally, we have 44.5 times 6. That gives us a 267. Now we have all our x's and then all our fx. So the last thing we need to do is to find the sum of, and that gives us a 660. That is 29 plus 122.5 plus 241.5 and then plus 267. So now that I have our sum of f of x, as we have gotten the sum of f of x values, we also need the sum of f. You see, so that is sigma f. And sigma f is just 2 plus 5, which gives us a 7. 7 plus 7, we have a 14. 14 plus 6, that gives us a 20. So we have these two values, hence we can find the mean of the data. So this is what we had. The sum of f was 20, sum of fx was 620. So we come and say our mean is equal to what? The sum of fx all over the sum of f. And that is what? 660 divided by 20. 660 divided by 20 gives us a 33. It means the mean we were looking for this group data here is what? 33. And that is all. Right? And if it's 33, then it means the mean is in this class over here. This class interval, the 30 to 39. The mean is in there, and it also has a frequency of 7. Right? Okay. So that ends it for this session. We have looked at what the mean is, and we have looked at the 3 ways we can solve our mean. When you are given a raw data, you just find the sum of the values, divide it by the what? Number of data values. If you have a discrete frequency data, all you need is your sum of fx. How do you get your fx? You multiply all the x values by their corresponding frequencies, then find their totals over here. Use this formula and you are good to go. Then the very last one, which we just did, that is for group data. You would have to look for your own midpoint. You see, so after you get your midpoint, you just follow that of the discrete values. So here are some questions you can try on your own to test your understanding. You can let me know in the comment section your answers, and I'll be glad to help as well. So there are just 3 questions. The first one in white, this one also in a little gray there, and then the third one also in what? White. Stay blessed and then have a nice day. Bye.